Okay, in the last video we set up an Aspen simulation for a flash and just put in reasonable values for temperature and pressure and input the composition of the feed. In this video I want to talk in more detail about how to get the answers to these questions. So let's start with the bubble point. So we not only want the bubble point temperature at 1 atmosphere of pressure, we also want the composition of the initial vapor that would be formed. Then we want the dew point, and then we want the temperature, we want to set the temperature at the average of the bubble point and the dew point, and determine the amounts of liquid and vapor as well as the compositions. And then finally, if we want to set the composition to 50% vapor, 50% liquid, and then determine the compositions. So let's go to Aspen. I'm going to start with something that I think is sort of the best way to initially learn, right? I think what I'm going to do is just fiddle with the temperature. Remember, if you look at the results summary, when we set it to be 100 degrees Celsius, what we got was mostly liquid. And so if I want to determine the bubble point, I can bring the the temperature down until there's very, very little vapor and mostly liquid. So I'm going to start by just manually bringing the temperature down. So 100, let's try 95. Let's run our simulation and look at the stream results. Okay, now, our molar flow, I thought I had changed that to mole per hour. Kilomole is okay, I guess, but I like to see that 100 mole per hour. Okay, it's all liquid, right? So I lowered the temperature too much. Let's go back to the flash. Let's go to 97. Run the simulation again. Okay, I still have 100% liquid. Okay, let's go back here. I can go here, 99, run. Odd. I thought 100 produced some vapor. It did. Okay, I guess I was very close. Okay, now I think I had lowered it too much. 99.9, run. Okay, so we can see that, it's interesting, it changes to kilomole per hour when I run a simulation. That's annoying. It's producing 95% liquid and only 5% vapor. That's pretty good. So it tells me that 99.9 is the bubble point, but let's try 99.8. Okay, so it's inching up. It's 4% vapor, right? So I can fine-tune this by fiddling with the temperature, but let's find a more accurate way to estimate the bubble point. I'll show you a different mode for the flash calculation. So instead of saying temperature pressure, where you specify temperature and pressure, you can actually specify the vapor fraction. And so now the temperature is no longer something you can control, but I can say a very small number for the vapor fraction, and I can run. Let's go to the stream results. This may be less intuitive, but you can see that there is a tiny amount of vapor produced here. And so if I look at the temperature, where does it say the temperature? Maybe if I go to results. No. Oh, here, temperature. The temperature that it gives you is the temperature of liquid and vapor output, and it's 99.05. Okay, so that's the temperature of the bubble point, because almost all of it is in the liquid, very little is vapor, but you can still get the mole fractions of vapor at the bubble point. Now, if I wanted to study the dew point, then I can try something that is very close to 1. Run that. And you can see that now under these conditions, there's very little liquid and almost entirely vapor. Let's go back to moles per hour as our unit. And you can see that it's 99.999% vapor, very little liquid, but here are the mole fractions for the composition of the liquid at the dew point. And so if we want the temperature is about 112, right? So the bubble point is about 99, the dew point is 112. I don't feel like calculating the average of those two numbers, so let's just call it 105. That's close. And so the last part of the question, part C of the question. So part A was I believe the bubble point, part B was dew point. Hopefully you can see how to do that. Repeat that I think it's intuitive to just manually specify temperature and pressure at first, but then once you feel comfortable with that, you can then specify the vapor fraction. Let's go back to temperature pressure mode. I can specify 105, go to my stream results, and you can see 105 gives me about a 65-35 split in terms of liquid and vapor, and then I have the concentrations, right? So that would be the answer to part C. And then part D asked us to find the temperature and composition with a vapor fraction of 0.5. So we can specify that here, run the simulation, stream results. Now we have an equal partitioning of the fluid from from pure liquid to liquid and vapor. The temperature is given, 107, and the mole fractions of liquid and vapor are given in this stream. So that should be the answers to all of the questions being asked. Let's take a quick look at the homework assignment. Okay, we calculated the bubble point. That was about 99. And the composition of the very first vapor formed That was the mole fractions given in the stream table. The dew point was when you had mostly vapor output and very little liquid, and you can get the composition of the liquid at the dew point from the stream data. And so once you have the bubble point, the dew point temperature, you can average those two, specify that temperature, then specify how much of the overall molar flow rate is liquid versus vapor, and you can specify the stream compositions. And then in part D, if you set to equal output of vapor and liquid by setting the vapor fraction, it'll tell you the temperature as well as the compositions of the stream. So I think that is how you get the information you want.